Today's lessons will cover graphing lines using intercepts, as well as covering horizontal and vertical lines. The objectives for this lesson are graph lines using intercepts, graph lines passing through the origin, graph vertical and horizontal lines, as well as solving applications involving graphs of lines. So here's the procedure to graph quickly. First, we get a definition known as the x-intercept, where we have a component, x component A, and a y component of 0 of a line. And here the point crosses the x-axis at this coordinate point. To find the x-intercept, let y equal 0 and then solve for x. Next, you take a look at the y-intercept. Here we define it as the x component to be 0 and the y-intercept point would to be B of a line. And this is the point again where it crosses the y-axis. Therefore, to find the point that is called the y-intercept, let x equal 0 and then solve for y. So let's look at this procedure once again. Find the x-intercept known as A, 0 coordinates. Find the y-intercept with coordinates 0 and B. And then graph these 2 points to form the line. We can also use a third point to check and see if the point is on the line. So let's look at an example using this process, graphing a line using intercepts. We're given a linear relationship here, 2x plus y equals 4. So for x equals 0, we substitute this value into this equation, which yields the following: 2 times 0 plus y equal 4, which yields y equals 4. So now we have a point located at x equals 0 and y equal to 4. We plot that point here, and we have this point where it's known as the y-intercept. Our next point is when y is equal to 0. So when you substitute y equals 0 in this equation, that yields the following: 2x plus 0 equal to 4. So we divide here in this result 2x equal 4 by 2, which yields an answer of x equals 2. Therefore, we plot the point here with an x coordinate of 2 and a y coordinate of 0, and this is known as the x-intercept, since this is the point where y is equal to 0 and it intercepts the x-axis at this point. Now that we have these 2 points, P and Q, we can draw a line through them. Now as a check, we can substitute for x equal 1, again for the same equation that we started off with. And then we have 2 times 1 plus 4, y equal 4. That yields an answer of y equals the 2. We plot this point where x is equal to 1 and y is equal to 2, and we see visually that it falls on this line that we just drew. So let's look at an example associating with graphing lines through the origin. In this case, we have our standard form of our linear equation, 2x plus y. However, this is equal to 0. Now we do the same process. X equals 0, 2 times 0 plus y equals 0, where we substituted x into this equation, and that gives us a point 0, 0 passing through the origin. When we have y equals 0, we're going to get the same thing where 2x plus 0 equals to 0, and hence we get the same point where x is equal to 0 also. But we need another point to draw a line. So we can take basically any point, for example x equal 1, and then we substitute it up here to get our second point. So in this case, 2 times 1 plus y equals 0, and when we solve for y, we get y equal to negative 2. So plotting this point, 1 and negative 2, we have this following point. Now we can draw a line between these 2 points, and basically through it. So that's how we do this line passing through the origin. And I have another demonstration where we can see the effect of this as we change the slope when we discuss the slope-intercept form. Now we're going to take a look at graphing lines. And what do we mean by graphing lines in terms that is horizontal? For this case, y is a constant and is not a function of x. What does that mean? Y is not a function of x. It means that no matter what the value of x is, we're still going to have y being a constant. So for example, let's say y equal 5. No matter what the value of x is, 1, 2, 3, 4, or negative 1, negative 2, negative 3, or negative 4, y will always equal to 5. So what we have, as shown here, is a horizontal line. Let's look at another example where y equals to 3. So in this case, we have another horizontal line located at y equal 3, no matter what the value of x is. Let's look at the negative y-axis, where y is equal to negative 2. And what we have is another horizontal line. But this time y is located at negative 2, and no matter what the value of x is, we have still a value of negative 2. And then finally we have y equal negative 4, and that's also a horizontal line. Now we can do a similar thing when we do vertical lines, but this time x is a constant and is not a function of y. So no matter what the value of y is, 1, 2, 3, 4, or negative 1, negative 2, negative 3, or 4, then the value of x is always a constant. For example, if x equals 3, we have a vertical line. And we see that no matter what the value of y is, that x is a constant 3. Same for x equal 1. We still have a vertical line no matter what the y value is. And same true with the negative x-axis, where x equals negative 2 and x equals negative 4. We have vertical lines. And then graphing horizontal and vertical lines, we just combine what we learned earlier. So in this case, we have 2x minus 4 equals 0. We have 2x is equal to 4. Solving for x by dividing 2 on both sides of this equation yields x equals 2. So we plot this graph for x equals 2, and that's the solution to this equation. Now let's solve for 3y plus 9 equals 0. Here we see 3y equals negative 9, and that yields y equal negative 3, where we divide 3 on both sides of this equation. Plotting that for y equal to negative 3, we have a horizontal line where y is equal to negative 3. So that concludes the graphing of horizontal and vertical lines.